Hello and welcome to the very first lecture in chapter 22 of our comprehensive course on machine learning, data science and artificial intelligence. Now, this is going to be a very important chapter because now we are entering into the real part of what you call machine learning. In fact, many of the courses that I have seen, they just explain starting from here. But I wanted to develop this course in such a manner that it teaches everything from scratch. So that is why we did around 16, 17 chapters whole on Python programming, then several chapters on statistics and various statistical tests. And now we are doing this part, feature engineering, that is data preprocessing. And with this, a little bit of this part also, that is model creation. So now we are in this boundary, we have decisively and conclusively converted, passed over this portion. That means data understanding, exploratory data analysis, and in between, it is not shown, but we had to do a lot of statistical discussion because when you do this model training and validation, then at that time, you have to be capable of interpreting the results which your algorithm is giving. So that's why a lot many chapters on statistics and various kinds of statistical tests, hypothesis testing, we had to do. Now we want to do this feature engineering, and as I said, we will in fact start with model creation of itself in this chapter itself. Okay, what are the parts of the chapter? Then first part is this, creating new features. Feature engineering means either creating new features or modifying the existing features so that they become more useful and they make the model, machine learning model, more robust. Okay, creating new features includes interaction terms. Now here as an example, we will create one multiplicative interaction feature. That is a new feature will be created by multiplication of two features which are given to our in our data set. Then create a polynomial feature. Again, polynomial feature is that sometimes we may find that linear models are not fitting. So at that time, whenever some feature is given, a column is given, then we will do square of that feature, right? Then encoding categorical variable. Now that we have done, one method we have done, that was one hot encoding, but other method so far we have not done, label encoding. So we will be doing that, one hot and label encoding both again. So it will be a good revision of one hot encoding and then label encoding. Part B of the chapter would be about data scaling and normalization. Now as such, almost entire this part D would be a revision because we have done detailed discussion of standard scaling and min-max scaling earlier. But we will do this discussion again because at that time actually we were compelled to do the discussion because some other topics which we were discussing, they would not be possible to explain. They were not possible to explain properly without doing this. So I had to explain these two steps that what exactly we are doing here. But there the purpose was not to understand this scaling, but the purpose was to understand that other topic. Okay, now this is something new, L2 normalization or Euclidean length normalization. So that we will see when it comes. Then introduction to feature selection techniques. Now these techniques are very broadly classified into filter methods and wrapper methods. Here this should be wrapper. WRAPPER. Okay, so filter methods and wrapper methods for feature selection. Then model evaluation and validation techniques. So in which introduction to model evaluation, what are some common metrics which are used for regression evaluation? For example, mean squared error, root mean squared error, mean absolute error, R squared. Okay, so we will see these things. And remember, these are only for regression. So we, in next chapter, when we do this model building, we will start with the simplest possible example, that is simple linear regression. So that is why we are at present introducing only the metrics for regression. We are not introducing the metrics for classification. That means how good your classification model is. Then there are again certain nice metrics by which you can decide the goodness of your classification model. But at present we are talking about only regression. So these MSE, RMSE, MAE and coefficient of determination or R square, these are only for regression. Then techniques for model validation. So we will do train test split cross validation and we will finally take code examples, explanations, etc. Then this is for part D. Now part E, introduction to scikit-learn library. It is imported as or when you install, then it is keep install scikit-learn. But when you import, then or when you write anything about it, this short form is used, sklearn. Okay, so sklearn, what is that library? What are core features of sklearn? What are some commonly used modules and functions? Then we will take some code examples using sklearn and so on, right? This will be core features of sklearn. Okay, then that will be pre-processing. sklearn is useful for pre-processing. sklearn is useful for model selection. sklearn can provide all supervised learning algorithm. sklearn can provide all unsupervised learning algorithm. Okay, then metrics for classification and regression both. So metrics for measuring performance of the model like accuracy, precision, recall, MAC, etc. And sklearn can even help to create pipelines so that our workflow, whatever we are doing, that is reproducible. Reproducible means once you create a pipeline object, then you can just use it again and again whenever new data comes. Because in any organization, whenever data driven approach is used, so at that time we don't use only one, right? We don't use the model created model only once. We want to use it for quite a long time, and during that long time our some new data will come, some new even features might be added. So at that time, if you have to do everything from the scratch each time, then that would be very inefficient way of doing data science. So we will create pipelines and we will reuse those pipelines again and again. So now you can see that if you read this portion, mod pre-processing and all that, that is, we are pre-processing is here, feature engineering, but then model creation and all that, that is coming to be here in training and train, test, split, all those things, that is coming in this part. So that is why this chapter and the next subsequent chapters, they are slowly going to this portion, this brown box and this pink or whatever color you call it, that type of box, right? Okay. And this scikit-learn is a new library that we are introducing. So almost entire data science can be done by limited number of libraries in Python: NumPy, Pandas, Matplotlib, Seaborn, Plotly, then SciPy, text models, and this scikit-learn. Scikit-learn is a super powerful library, and other libraries are just useful for up to this stage of data science lifecycle, that is exploratory data analysis, and to some extent maybe feature engineering. But scikit-learn is useful for all almost all stages of data science lifecycle, right? Okay, so let us start with the first part, creating new features. So in creating new features, first we are talking about interaction terms. Now in interaction terms, there are two cases. One, I will call it A and this B. So a multiplicative interaction terms and a polynomial interaction terms. So currently we are focusing only on this. In some other chapter, we will be focusing on this, encoding of categorical variables. Okay, but currently we are doing only this interaction terms, and it is relatively easy topic. So what are interaction terms? Interaction between features can provide additional information which is not available through individual features alone. Now, whenever you do regression or classification, most of the algorithm believe or take it as an assumption that various features in common language, various columns, they are independent of each other. However, in many cases, you will find that these various features are not independent. So in that case, you have to study how much, whether they are affecting each other, one column affects the other column, and if yes, then to what extent. And in fact, more important is not the interaction between two features, but how the presence of one column affects the interaction of other column with the response variable. So if I am predicting the salary based on only two features, age of the employee and educational qualification of the employee. Now the question is, age interacts with salary in its own way, and educational qualification interacts with salary in its own way. But the question is, if educational qualification alone is there, then the way it interacts with the salary, that is your response variable, which you are trying to predict, does the presence of each other column affect the interaction of this educational qualification with salary? Okay, that is one thing. One other thing is that similarly, age affects the salary response variable, but does the presence of educational qualification, the second column, affect the interaction between the first column age and the response variable salary? So all such studies are done in this interaction effects. But here we want to create interaction terms by ourselves. Ourselves means we think or we just take an assumption that if there are two columns, then let us make first a model taking each feature on its own, but then make another model in which we add one column, which is say product of column 2 and column 3, or feature 2 and feature 3. Or we can make another column which is the sum of feature 2 and feature 3. So some kind of interaction between two features is done. And does it improve the robustness of model? Does it reduce the error? Does it improve the generalizability? Does it improve the accuracy, precision, recall, etc.? So study of those kinds of things, that is interaction. So let us create first a data set. Here we are not creating a data set, but rather we are loading a data set which is directly provided in the scikit-learn library. Remember, first step before this should be that import scikit-learn. I think that step is missing here. Okay, so perhaps, okay, here it is working because I have already imported a, okay, yeah, it is there, right, fine. This is import fetch California housing. Now what is this fetch California data set? Before this data set was developed, one other data set for housing price prediction was very popular, and that data set had was called Boston housing data. However, just recently, that means as I am recording in 2024, maybe it was in 2023 end or 2024 beginning, it was found that that Boston housing data set had was having some ethical issues, and it was not unbiased data set, which is the important requirement. So that is why nowadays it has been removed. Still, you can get it from internet, but it is not advised to use it except for educational purpose. Okay, so that is why instead of Boston housing dataset, we are using California housing dataset. So this is the data imported from sklearn library. Okay, and pandas is as usual imported. This is one important option which we are setting because you will see that later on we will require this option. We have earlier seen that option. That otherwise what happens is sometimes if there are say 100 columns, then Jupyter Notebook will try to fit all the columns, but if it cannot fit 100 columns, then it will fit say first 5 columns, then dot dot dot, and then next 5 columns, right? That like that, right? So that would be very uninformative type of output. So we want that display max columns is equal to none. None means how many max columns you should display. Then none means no limit on the max columns, or in other words, that means that show all the columns. So even if there are 200 columns in the Jupyter Notebook, here in the output cell, a scroll bar will come at the bottom, and you can scroll it right or left, so that 200 columns or even 500 columns, any number of columns would be visible, right? Okay. Similarly, this is another option which I have not yet executed. That is display dot max underscore rows, and that is equal to none. If I execute that, then in that case, when I write a df, that is a data set which is imported and loaded in my pandas, in my Jupyter, sorry, that if I write df, then all the rows will be displayed. Here I am not executing that option because you can see that the data which we are going to use has 20,640 rows, right? So that would be very unwieldy. I have to go scroll all the way to the bottom just to show the output of the data. Okay. So we are loading the data fetch underscore California underscore housing, and that becomes our data. But that data is not in data frame format, while we will always and always in whichever form the data is there, it is very helpful to first convert it into pandas data frame, right? So that is why if I show you what kind of data is this, then you will see that it is not helpful to keep it in that manner. Okay, so this kind of data you will see. It is in array format, and see how it is. Okay, it is very unwieldy to do anything with that kind of data. But now I am converting that data into data frame, pd.data frame, and I am writing data.data. That is which data to be taken, then this data to be taken, and columns equals to data.feature names. Okay, that you will get on your own because you know that now data dot, and you push the tab characters. Here I think it is not getting displayed. I don't know because perhaps I have already executed the cell. That is why it is not displayed. But if you write, yeah, now it is displayed. Data dot data. So that would be somewhere. That data should be there. Yeah, perhaps data dot values also I can write. Okay, but here let us keep data dot data because it does not make any difference in this case. And here data dot feature names, that is the column names which is there in the data. Now here pandas has converted it into a nice looking data frame. This is the information about the data which I have taken. So whenever you get any new data, this is a very good habit. If some data is directly loaded in your Jupyter Notebook, then go to Google and type California housing dataset. So as soon as I type it, I see that California housing dataset and all that. So it is on Kaggle, it is on GitHub, but it is actually directly from scikit-learn. So I will prefer to open this page, Fetch California Housing. And when I open that, it will show me that how to load this sklearn.datasets, Fetch California Housing, and these are various options also. Okay, so download if missing is equal to true and all that, right? And it gives that it should have this many rows, this many columns. All features are real, so that means this is a real data set. Real, I think here means real number, and the target is also a real number. And then read more in this user guide. So when I clicked that, I got this. That is called data dictionary. So whenever you get any data, And as a data scientist, if you work for some uh, organization where a new data is given to you and you are asked to do complete data analysis, build the model and everything, then you can always ask that give me data dictionary. Okay. So if you get that data dictionary, then here you can see that there are this many rows, these many columns, and each column means what that is also given. So these only I have just copied and pasted in my Jupyter notebook. Okay. So these many rows, these many columns, and one column is med inc, that is median income. It is the median income in the block group. Another column is house age, that is house age of the house in the uh, block group. Average rooms is the average number of rooms per household, and average bedrooms is the average number of bedrooms per household. Population is the block group population, okay, and average occupancy is the average number of household member. Okay, so in each house, how many household members are present? And since it is a Western data set, mostly families are nuclear, so that is why 2 or 4 or that kind of output is seen, but not many, not joint families are there. Latitude of the block group and the longitude to specify the location of the house in perfect manner, right? Is there any missing attribute value? Then that is given as none. Now, this is what they have given, and even if they have not given, you can find all this information, but this you will not get from anywhere. That what does this med inc mean? What does this L rooms means and L bedrooms? What is the difference between L rooms and L bedrooms? Okay, so that you can ask for the data dictionary. Now, once you get the data, I always show you that as soon as you get the data, a few steps we should always do. So those steps here are not shown all, but we should always have a habit of doing these few steps. One is df.shape. So that will give how many rows and how many columns. So 2, 0, 6, 4, 0, and 8, right? Then df.info. So that will give me the data type of each column. So here each is float. That was the meaning of that all variables are real time. Okay, and the memory usage and non-null count is also given in each column. The non-null are equal to the total number of rows. That means practically there is no null value in this data set, right? One more, if you want to write, you can write df.describe, because all are numerical variables, so you can get the statistical summary of them. Okay. Now in median inc, that is the median income. If you see, because this seems to be median income in some maybe $1,000 or maybe $1,000 per month. That looks to be more likely, right? So because $3 or such values which are given, that is not possible for a month. So it will be maybe in thousand. Now if you see the range, then the minimum value is 0.499 and the maximum value is 15. Here minimum is 1, maximum is 52. So okay, the scale looks more or less same. But here minimum is 0.84, maximum is 141. So the scale is now slightly expanded. 0.33334 more or less same as the first two columns. But here if you example see population, then 3235682. Now that is a big scale. So this will tell us that some kind of feature scaling or normalization would help in making more accurate model, right? Average occupancy also, then that will also tell me if there are some outliers or not, right? So then this is the minimum value for this latitude. Now in latitude and longitude, there is not much sense of looking at minimum maximum values, right? If you want to draw, if you want to do, then you can write still df.d types and all that, but data types are already seen here, so it is okay. Then some df.duplicated if there are duplicate rows, right? So then that will give if there are duplicate rows present in my data set. So here I have done some df.duplicated and I got 0 as the answer. So that means there are 0 duplicate rows. Or this is a nice data set which is reasonably clean, because we have done exploratory data analysis, that is this part in much detail. So now we know how to do deduplication, then how to fill the non-values. So now our focus is not on those things, but our focus is on learning something further, feature engineering and all that. Now feature creation. So as I said, what are the columns at present, or how many features are there at present? So you can write df dot columns, and these are the columns at present: median income, house age, average rooms, average bedroom, population, average occupancy, latitude and longitude, right? Now suppose I want to add one column. Why at present? Don't worry. But suppose I try to find some model using this originally given column, and in spite of trying several different algorithms, I did not get sufficiently good metrics. So it was not a good performing model, and therefore I decided that maybe let us try product of two. So I am trying to find product of made inc and house age. So this column multiplied by this column, whatever that value may be, So you can even here see this is the top rows. So this is the 8.3252 for 0th row and multiplied by house age 41. So that is the 48 are around 320 and 1 8 are, so that is 328 and something more than 328, around 329 or maybe 330. Roughly that kind of values you should see in the 0th row, and an extra column is added. This is that extra column. Pandas adds extra column always at the end. So these were the original column, these were, and this is the extra column which is added by house age multiplied by med ink interaction. Now here I have just blindly added the column, okay. Otherwise, it would look that what is the sense in that, because age is in years and median income is in maybe dollars or $1,000. So don't worry about that thing. We will see later on that which variables are to be chosen for the interaction or for such multiplication. There exists some logic behind that also, and we will study those things in detail. But at present, just think that suppose that logic has told you that if you multiply these two house age and med ink column, then in that case, these 9 column data sets, 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah, 9 column data set would give better accuracy perhaps than that original 8 column data set, that is only this one. So you added 1 column. This is called multiplicative interaction. Similarly, I am not showing it, but here at least means it is not shown in the Jupyter notebook, but here instead of multiplicative, it can be additive interaction. So at that time, I can do sum of these two. Again, for doing the sum, you should be able to do, you should have both in the same units. So instead of that, I am just doing average. Okay, let me add another only, that would be better. Another cell in the Jupyter notebook. But those who are having the printed version, they will not get it this way. So they will, because addition example I have not shown, right? So, okay. So they will get this multiplicative only. They will not get that additive. Right. I'm keeping the old as it is. Create a new additive interaction feature. Now df rooms is equal to df ave rooms. Now when you create this new feature, this spelling, etc., they are important, and that is why your copy paste is good thing for avoiding silly mistakes. So this is a new column being added in the original data set, which is the sum of these rooms and these rooms, right? So if you see now, still a new column is added, total number of rooms. Now many times these type of things are helpful to simplify the model. For example, if you find after analyzing your original data set, you find that there is these two variables, average rooms and average bedrooms, they are highly correlated. So in that case, say 99% or 95% correlation exists. So you may choose to remove them. But when you remove them, you are losing some information. Remove them means remove any one. But when you remove anyone, then you are losing some information. But instead of that, you can do one more thing also. You can add a new column in which the two highly correlated features are added together. And once that new column is added, you can drop the both original column, because all the information of average rooms and average bedrooms, that is already captured in this rooms column, right? So this is one thing. Now creating polynomial feature. So for that, polynomial feature means squaring or cubing or some that kind of taking square root also. It's not always necessary that index must go on increasing. Now it is possible that you modeled your data using the originally given 8 columns, but you found that in spite of doing all the efforts, sorry, in spite of doing all the efforts, your model is not satisfactory. So at that time, you can do this thing. That is, one, you can do that multiplicative or additive feature addition. You can also do this kind of squaring thing. So instead of taking a feature as it is, that is, for example, this median income, I am taking median income squared. So again, a new column is being added, and that is median income squared. So those two were already there. This was added by multiplication of house age and median income. This was rooms, which was created by addition of average rooms and average bedrooms. And similarly, this is the square of median income. And once you find that after adding this, you should drop median income and you should build the model again. And if you find that yes, the model which you are now building gives better metrics, it is highly generalizable also, it has no overfitting, but still accuracy, etc., on both train and test set are pretty high. So in those kind of case, you can, instead of keeping the original column, keep this column. However, the decision whether you will square or not, that will depend upon the scatter plot. If the scatter plot shows that whatever response variable is that is changing linearly, then you will not square it. But if the response variable is changing parabolically with median income like this, so in that kind of case, parabolic graph is a square, and then you can use that kind of feature engineering. Sometimes you may find other kind of graphs also. For example, let me show you that also. So the upper one, black color dots, if that kind of scatter plot is obtained, then you will do something what we have done. That is, instead of median income, you will take median income squared, because this is a typical graph, parabolic graph for y is equal to x square, right? This one. But this is the equation for the graph. But if you get this kind of lower graph, this kind of scatter plot which is obtained by black and red combination, so in that case, it is the graph of y is equal to 1 upon x or something similar to that. And therefore, you will say that as x increases, y decreases. So here you can add another column, which is instead of median income squared, you can write median, maybe suppose you are predicting price, then in that case, price would be perhaps inversely related to the house age. So as the age increases, the price decreases. Very old house may not fetch good price. Of course, that is subjective, because sometimes if the house is old, that means that the neighborhood is well developed, and perhaps when that house was built at that time, it was a small neighborhood, but now it has become a posh area. But assuming that with age the house decrease, the price decreases in your data set. So in that case, you can plot another. You can add one more column, that is df reci underscore house age. That is reciprocal of underscore house age, and that you can write is equal to df house age 1 divided by df underscore house age. So that would be another column which is added. So there is no end to this. And unfortunately, there are many methods for doing so many things related to the data science by automated library. For example, hyperparameter tuning now you can do automatically. Grid search, CVM, k-fold cross validation, and all those things you can do automatically. Even model selection you can do automatically by brute force method. Earlier it was an art to select appropriate algorithm and all that. Still it is an art if you do, but one can go by brute force method, that okay, you are doing a regression problem, then let me use something called auto ML, which will try all possible, or at least whatever you specify. You have specified 5 algorithms, it will try 5 algorithms whichever you have specified, and it will give you that the best possible algorithm is this. So many things have been automated, but this feature engineering thing, that is still something which is required for which is to be done, number one, by intuition of data scientists, and that intuition comes with experience. That if he has seen several different types of data sets and several different business problems, then he would be able to perhaps do better feature engineering. And second, it depends upon the domain knowledge also, and third, it depends upon trial and error. So that is why you have to try different features in this manner, and whichever build the models again and again. And when I say again and again, remember, you don't have to do the whole process again and again, because we will see that we'll make a reproducible pipeline, and in which you will first time put df original data frame without any feature engineering. Next time you will put say df1, in which you have done one only feature engineering, maybe this feature engineering product. Next time you will put df2, in which that feature engineering multiplication as well as additive feature engineering is done. Next time in same function you will put df3, and so on. So same function, reproducible code will be just used with different data frames, and it will give quickly the output of the matrix. Then you have to choose which feature engineering worked the best. And as I said, there is no automated method. Some hints exist, but there are no automated methods for doing this. Okay. In next lecture, we will talk about encoding categorical variables. As I said, that includes discussion about one-hot encoding and label encoding, of which one-hot we had done, but we are now going to do in proper manner, and label encoding was not done, so that also we will take up. So see you in the second lecture. This was the end of first lecture. Thank you.